Okay, we're going to go over the answers to the predicting products of chemical reactions worksheet to make sure everybody understands exactly how to do this. So the first one is synthesis. We know it's synthesis because we just have two elements, and when we put them together, we're just going to write the formula like you have to. For magnesium iodide, since it's +2 and this is -1, it has to be written MgI2. We know it's a solid because it's an ionic compound. I should have provided our physical state symbols here. I would definitely do that if it were a quiz or a test. And then it's already balanced. The second one is combustion. How do we know that? Well, if you have some hydrocarbon, which is carbon and hydrogen combination, or carbon, hydrogen, and oxygen, like a sugar molecule here, plus oxygen gas, we always produce carbon dioxide and water. So that's what we have here. Of course, they're both going to be gases because, well, it's hot, it's on fire, so they're going to be gases. And when we balance it, we get 2, 11, 8, and 6. Number 3, it's going to be double replacement because we have two compounds here. So the sodium and the hydrogen are going to switch places. So now we have sodium perchlorate. And when I look that up on my solubility table, that is aqueous. And then we're also going to make water because we have H go with OH, and that's going to be a liquid. And it is already balanced. Number 4, this one has a couple of hints here. If I gave you a decomposition reaction to predict the products for, it would simply be one where it just breaks down into the elements. This one was a little bit harder. I gave you some hints. I said with zinc oxide, which is written ZNO, which is solid because, again, I should have told you this was a solid. We're heating up. It's just going to decompose. It's going to form this ionic compound, so it's a solid, plus a gas that's used to extinguish flames. So I knew it couldn't just be oxygen gas because that would make the flames be more robust. So it has to be carbon dioxide gas. And then it just happens to already be balanced. Number 5, we have a single replacement reaction because we have one thing that's looking to replace something else in this compound and take its place. So we use our activity series. We see that zinc is definitely above hydrogen, so it can replace the hydrogen. So now hydrogen gas is by itself. Zinc is bonded with the chlorine. I should have told you that this is aqueous. This is solid. For single replacement, it's always going to be like that. And so then this is also going to be aqueous. And when we balance it, that's a 2 there, and the rest is good. Number 6 is also single replacement. Sodium, can it replace magnesium? We go look on the activity series. Yes, it can. So magnesium is all by itself. It's just a metal, so it's solid. And then we make sodium chloride. That's how we have to write the formula. It is aqueous. And so when we balance it, we have a 2 here and a 2 here. Number 7, double replacement. So when the calcium and potassium trade places, now I have potassium chloride, which is aqueous, and calcium nitrate, which is aqueous. So we have 2 aqueous solutions. So therefore, this has to be no reaction. We don't need to bother balancing it because it's not actually a reaction. Number 8, synthesis, because we have 2 elements. They're going to combine and just make the compound that they make, potassium chloride, which has to be written like this. Again, this is going to be a solid. It's an ionic compound, so it's going to be a solid. This should have told you this right here, but the idea is there's no water around, so it can't be aqueous. We balance it, we get a 2 and a 2. Number 9 is a double replacement reaction because we have 2 compounds. So the barium and the potassium are going to trade places. So now the potassium is with the chlorine. That's how we write potassium chloride. It is aqueous. The barium is with the phosphate. Barium's +2, phosphate's -3. So that's how we have to write the formula for barium phosphate. And look on our solubility table, we see it as a solid. So this reaction does happen. And when we balance it, we get 3, 2, 6, and 1. And just thinking about it, when you write the products, it would not matter what order they were in. It would be perfectly fine if you guys had written this product first and this product second. It doesn't matter at all. Number 10, another double replacement reaction. So the lead and the potassium are going to trade places. So now we have potassium nitrate, which is aqueous, and then lead 2 We know that it's lead 2 because it's lead 2 over here. So lead 2 hydroxide, which is solid, so we have a reaction that happens. When we balance it, we have a 2 in front of KOH and a 2 in front of KNO3. We're almost there. Number 11, single replacement. When I go look on my solubility table, I see silver is lower than calcium, therefore it cannot replace it. No reaction. Number 12, single replacement. When I go look it up, I see nickel is above hydrogen. And so many of you probably wrote this out saying nickel replaced hydrogen. So we have hydrogen gas and then nickel. Remember, if we don't know what the charge is, it's going to be 2. So this would be nickel 2 oxide, which is a solid. And I would have counted that correct. That's perfectly fine. Technically, it's no reaction because if you read the fine print on your activity series, it says that nickel can only replace hydrogen in an acid, not in water, but I would not be giving you one like this on a test. So if you have this all filled out, that is fine. If you read the fine print and noticed it was no reaction and put that, that's fine too. Number 13, single replacement. Can zinc replace copper? Yes, it can. So copper solids by itself. This is how we write zinc nitrate, aqueous, and then we go to balance it, it's already balanced. And the last one is a combustion reaction. So our products are carbon dioxide and water. They're both gases. And when we balance it, it's 1, 9, and then 6 and 6. So make note of any questions you might have so you can ask me in our next class period. But that would be the answers for our predicting products worksheet.